It's test time. I love tests. They're the best. Alright, really not that great. Anyway, light's a little messed up. Hold on. What the heck? Ah. That's better. I just want to make sure you can see my bright and shining face better. Light shining. So, we're Unit 10. We're getting close to the end, kids. If you have not bothered to do the practice test yet, and you're here to steal my answers, shame on you. Shame on you. Get your butt working on those problems. And then come and check your answers. And if you don't understand a problem, then come see me. Okay? So, don't cheat. We're going to learn a little bit of something new first, and it's probably what I've covered in class a little bit, so if you want to fast forward, if you already know how to do this. My pen was just working. If you already know how to do this, then that's great. If you don't know how to do this, that's not great. Oh, I can't find my mouse. There it is. Okay. Maybe it'll work now. Let's see. Yes. Okay, so kids. No, it's not working. Oh, there it is. Oh, man, this is going to be rough. It's going to be a rough day. Get rid of all these marks. All right, draw. All right, so anyway, something you know, and we've already talked about this in class, but hopefully you know this. Okay, so something you already know. You already know that the sine of 45 is equal to the square root of 2 over 2. And then isn't cosine of 45 also equal to the square root of 2 over 2? Sure. Yeah, great. And then isn't the sine of 1/2, or excuse me, the sine of 30 1/2? And let's see, when does cosine equal 1/30? Cosine equals 1/2 at 60. And sine of 60 is the square root of 3 over 2. When does cosine equal square root of 3 over 2? And that's at 30 degrees, square root of 3 over 2. So do you see any patterns being developed here? For example, 45, something between 45 and 45, or something between this 30 and this 60, and something between this 60 and this 30. Did you notice that they all add up to 90? 60 and 30, 45 and 45. And that would be true. So cosine and tangent, or excuse me, cosine and sine, they're cofunctions of each other, are equal to each other when their angles add up to 90 degrees. Or another way to say it is the sine of, let's call it x, is equal to the cosine of 90 minus x. And it doesn't matter what you pick for x. I could have the sine of 70 is equal to the cosine of 90 minus 70, which would be 20, as long as they add up to 90 degrees. And that is true for any of the other cofunctions as well. Secant of x is equal to the cosecant. I shouldn't have written it like that, sorry. I was going to write out cosecant, we'll just do the abbreviation. So is equal to the cosecant of 90 minus x. These two things just have to add up to 90 degrees. Same thing with tangent. The tangent of x is equal to the cotangent of 90 minus x. So, giving you a typical example, I could say the tangent of 80 is equal to the cotangent of 10. Or the secant of, I hope I switched these problems, the secant of 15 is equal to the cosecant of 90 minus 15, which is 75. Well, that comes into play in some of these problems. For example, I want to know when the cosine of 3a is equal to the cosine of 2a. I want to know what the value of a is. Well, it's very simple. I just take 3a and I add 2a, and we know that if they're equal, they have to add up to 90 degrees. So equals 90. Or 5a equals 90. Or when I divide by 5, I get a equals 18. Here, cotangent has to equal tangent when the two angles add up to equal 90 degrees. So if I do this, x plus 75 is 90, then clearly x has to be 15 degrees. Now it gets a little bit more complicated. These two are equal to each other. These two are equal to each other when the 4x plus 5 angle, whatever that is equal to the, not equal to, excuse me, when the 4x plus 5 plus, I forgot the plus the 3x plus 1 add up to equal 90. And I just got a simple equation. 7x plus 6 equals 90. 7x equals 84, or x equals 12. Let me see if I fix these problems. Looks like I did. Same thing. We're going to add these up to equal 90. So 8x minus 3 plus 4x plus 21 have to equal 90. This is true of all cofunctions. As long as these are cofunctions, they're going to equal each other. So they add up to equal 90 degrees. So add these up, I get 12x plus 18 is equal to 90, or 12x is equal to, oh yeah, that worked out, 72, or x equals 6. And finally, the last one. Let's see. 10x minus 50 plus 6x plus 20 have to add up to 90 degrees because it's sine and cosine. They're co-functions of each other. So I get 16x minus 30. Oops, that's a 90. Minus 30 has to equal 90. Or 16x equals 120. Divide by 16, divide by 16. Let's see if I can do this without a calculator. If I cut them both in half, I get 60 over 8. If I cut them both in half again, I get 30 over 4. And let's see, that would be 7.5. And you could always just use a calculator to figure out what this is. It's 7.5. And that's okay. You're in trig. You can get a decimal. All right, let's start review. All kinds of random review. Simplify the expression. What did I tell you guys when you see a double angle? Oh yeah, you have to replace it. If you don't know what it is, you go over to your formula sheet. I was going to close this because it's still a mess from the last time I used it. But that's all right. Leave it up. And hopefully you remember that it's equal to 2 sine A cosine A. So if I simplify this, I know that sine of 2x is equal to 2 sine x times cosine x all over sine squared x. And then I got to start simplifying. Got to be careful here. This sine x cancels with the squared because it's kind of like x and x squared. It gets rid of 1. So I'm left with 2 times cosine x over sine x. But that's just 2 tangent x. There's my answer. One done. Yay! 23 to go. Woohoo! Again, here we go. We got a double angle formula. We're going to replace this. I'm also, since that's just going to give me cosines, I'm also going to replace that with what I know that to be. So that would be 1 over sine of A times, and I'm going to put this as a fraction too, 2 sine A times cosine of A all over 1. And then I'll start lopping stuff off. The sine A's cancel. And I'm left with 2 times cosine A. Ka-chang! 2 done. Getting there. Alright. So what are we going to do with this? Oh, I see a double angle. This double angle needs to be replaced. Let's start with just that. Let's just start with that. Now, if I'm looking at the top, I'm thinking, if I'm going to replace that, I'm probably going to want to replace that with something I can match up with sine squared theta. So I look over at the formula and I see, oh yeah, oh, it's even the one that's circled. I want this one that's got the sine squared in it. So I'm going to replace it with 1 minus 2 sine squared. Let's see what we get with either that. That's not what I want. So I'm going to replace it with 1 minus 2 sine squared A. So that's what I replaced. That's this. And then everything else I'm just going to copy down. Plus sine squared A all over cosine of A. Well, if I take care of the numerator, you got to be careful here. That's 1 minus. Now, if I have minus 2 sine squared A plus 1 sine squared A, that just gives me minus 1 sine squared A over cosine A. Well, what is 1 minus sine squared A? I'll write it over here. I'm going to have to get rid of it. But remember, do you remember this one? Sine squared A plus cosine squared A equals 1. And if I want to figure out what this actually is, I'll bring this over here. So I have cosine squared A equals 1 minus sine squared A. Kind of fit that in there. So therefore, I can replace that with cosine squared A. That's what this is equal to. All over cosine A. Well, now I can just simplify. This cosine A cancels with this cosine, and it leaves me cosine A. There's my answer. Done. All right, let me get rid of this. Pen's working great. I know I just probably jinxed myself. Go black and red, black and red, black and black and black and red. Oh, in which interval does f of x equal cosine x? Is the inverse also a function? Let's think about that. Why am I doing cosine? I should be doing tangent. Zero, 90, 180, 270, and somewhere over here is 360. So clearly this passes the vertical line test so that it is a function, but it fails the horizontal line test like this because it's got a piece that comes down and it's got a piece that goes up. So if I were to get rid of from here over, so this no longer existed, this part right over here doesn't exist, then if I were to then, let's try this, draw in vertical lines, it wouldn't, since this isn't here, it's not going to hit it, correct? So if I can restrict it from here just down to here, then it would be, then the inverse would be a function, because then it would pass the vertical and the horizontal line test. Therefore, the answer is from 0 to 180 degrees. Or, if you'd prefer, from 0 to pi. Inclusive. Done. Write the equation of the graph below. Well, the first thing I got to do is figure out where the midline is. Top is 8. The bottom is 2. That's a difference of 6. So I got to go up 3. So the midline's right here. At y equals 3. So whatever my function is, at the end I'm going to have a plus 3. I don't know why I put a plus c. That's really weird. I have no idea where c came from. Alright, so plus 3. Now, what's my amplitude? Well, to go up and down, we already figured we're going to go up and down 3. Sorry about that. So my amplitude is also 3. Because my midline, from my midline up is 3, and from my midline down is 3. So my amplitude is 3. Let me, excuse me, let me erase that 3. Put it back in. But I'm starting at a minimum and I'm ending at a minimum. Well, let's see, starting at minimums and ending at minimums, I know that's cosine. And I also remember that because it starts at a minimum, that means it has to be a negative cosine. So now we're at negative 3 cosine. Now, how much do I finish in? Oh, man. I finish one curve in 30. So I know that my period is equal to 30. Now I got to figure out what my b is. Well, isn't period equal to 2 pi over b? So isn't 30 equal to 2 pi over b? So I can cross multiply. I get 30b equals 2 pi. And if I solve for b, I divide by 30, I divide by 30, and I get b equals 2 pi over 30, which is really pi over 15x. And there's your equation. So let me write it up nice and neat for you. F of x equals, that was a really hard one, 3 cosine pi over 15x plus 3. All right, children, let's get this up here a little higher so it's away from my head. Find to the nearest degree all the values in the interval from 0 to 180 degrees where this is equal to this. Now, did you notice that we've got a mess here, right? I've got kind of a mess here. Wait a second. 1 over cotangent theta. Isn't 1 over cotangent theta really equal to tangent of theta? It is. So I've got 3 tangent squared theta plus, this thing just converts to tangent theta. And I'm going to bring the 2 back over, so I get minus 2 equals 0. Let's say you're not a fan of factoring. Let's practice. Menu 331, not that. Go to calculator. Menu 3, 3, 1. Boom. There it is. Click OK. Now my numbers were 3, I believe 1, and I believe also negative 2. Hit OK. That's my quadratic. I'll solve that. Negative 1 and 2/3. So I'll go back. So I know that tangent theta is equal to 2/3. That's a 3. That's not a 3. Tangent of, great, delete half of everything. Tangent of theta is equal to 2/3, and tangent of theta was negative 1, was it not? Let me just make sure. Perfect, negative 1 and 2/3. So here we're going to put in tangent theta plus 1. And if you remember correctly, this 3 goes up front, so this is going to be 3 tangent theta minus 2. Everything goes back in with an opposite sign. Okay, so if you did the inverse tan of 2/3, tan negative 1 of 2 divided by 3, I get 33.69. 33.69. And they want me to round to the nearest degree, so we'll say theta equals 34. And I know when tangent equals 1 is 45. Now again, if you forget, if you haven't memorized that, you can always do inverse tan of 1. It's kind of embarrassing that you have to do that, but if you have to do it, do it. That's 45 degrees. Now, since it's negative, I'm not keeping that 45. Oh, wait a second. Hey, let's talk a few things. Also, it also says I'm only picking them between 0 and 180, so I got to be real careful with that. So I will keep the 34, but the only other place that tangent is positive is in the third quadrant, and that's bigger than 180, so I'm not going to do that. Tangent is negative in the second and fourth quadrant, so I don't need the fourth quadrant, but I do need the second quadrant, and the 45-degree angle in the second quadrant is 135 degrees. Done. 6 done. Find all the values from 0 to 360 that this equation is true. All right, so let's write this equation. Tangent of theta plus 2 tan theta times sine theta equals 0. Now, you can replace a squared or a double angle, but I don't have a squared, I don't have a double angle, so what are we going to do? This is one of those ones that when you see it or when someone tells you to, you're like, oh, I get it. But sometimes you don't see it. Do you see that we have a tangent here? And do you see that we have a tangent here? They have a GCF. And that GCF is tangent of theta. So when I take the tangent of theta out, I'm left with 1 plus 2 sine theta. That's all the factoring that you have to do. Now you just got to set these things equal to 0. That's kind of the tricky part. Tangent theta equals 0, and then 1 plus 2 sine theta equals 0. Well, that one's all set. This one gives me sine theta equals negative 1 over 2. Hopefully you see that. I brought the 1 over, made it negative, divided by 2. All right, so let's see. I know that theta equals a half at 30 degrees, but this is negative a half. So I know that 2 of my answers are going to be in the 3rd and 4th quadrant. 210 degrees, that's the 3rd quadrant angle, and the 4th quadrant angle would be 330 degrees. That's where sine is negative a half at those 30-degree reference angles. Now this one's a little tricky. You can either memorize when tangent's equal to 0, or you can remember that tangent is really sine theta over cosine theta. And this is only equal to 0 when sine is equal to 0. So let's take a look at the sine graph. The sine graph looks like this. And it is equal to 0 at 0 degrees, 180 degrees, and 360 degrees. Do we include 360? Yeah, we have to include the 360. So I get 3 more answers. My 3 other answers are going to be 0, 180, and 360. Those are my 5 answers for that one. All right, kids, let's work on this next one. Oh, yeah. Oh, yeah, we got some problems here, kids. All right, so let's take care of this. First and foremost, I see tan of A plus B. That says to me, go over to your formula, crazy. I see exact. I want the exact answer. It doesn't say exact, but it should. And here it is, right here. Tangent A plus B, right there. That's the one I want. So I'm going to use that one. Tan A plus tan B. Tan A plus tan B all over 1 minus tan A, tan B. Don't think you know, check. Make sure you know. 1 minus tan A times tan B. Now, everywhere I see something I'm going to replace, I'm going to put parentheses. So, tangent A goes here, minus, plus. Tangent B goes here, all over 1 minus. Tangent A goes here, and tangent B goes here. Now, I was a little bit nice to you. Not really nice to you, but I was a little bit nice to you. I told you what tangent A is equal to. It's equal to 2/3. So wherever I see a tangent A, if I can do this correctly, I should be able to use the back of my thing. 2/3. I just don't know what tangent B is equal to, but I was given some information about tangent B right there. Or I was given information about the sine of B, or a little bit of information about angle B. So let's talk about it. First of all, it's in quadrant 1. That helps us out. We're going to draw a triangle in quadrant 1 for triangle B. And I was told that triangle sine of B, sine is opposite over a hypotenuse, square root of 41. Well, because I gave you some obnoxious square root there, I'm pretty sure this is going to turn out to be a nice one. So let's just check it out. 5 squared plus, this is going to be x, plus x squared equals the square root of 41 squared. So this is 25 plus x squared equals positive 41. Subtract 25, you get x squared equals 16. So x equals 4. So now I know that this is 4. So tangent is opposite over hypotenuse, 5 over 4. Well, since all of those are relatively nice numbers, I can just come over to my calculator and type those in. So I go, control division, and then I'm going to type in parentheses. Always use parentheses. It takes a little extra time. Just do it. 2 over 3 plus parentheses. Control division. 5 over 4. All over 1 minus parentheses. Control division 2 over 3. Like the added extra steps that you have to do, it's times, control division, is not that much that you shouldn't do it. So you know that you got it right. Hit enter, and I get 23 over 2. And there's my answer. My answer is 23 over 2. Right there. Moving on. Find the exact value of the tangent of 1/2 of A. All right, well, that's plus or minus. Let's take a look what it is. It's right here, down at the bottom. Tangent 1/2 of A. That's 1 minus cosine over 1 plus sine. So it's 1 minus cosine A, or x, or whatever we're working with, 1 plus cosine A. I was so good to you. I'm like, man, I'm like the goodest person ever. This is equal to plus or minus. We'll talk about the plus or minus in a minute. 1 plus over 1, excuse me. It is 1 minus on top, right? 1 minus on top. That's what I thought. Got a little mess up. See, that's where you make, that's where a simple little thing, just guy moving along, not taking care of, not thinking about things, you can really screw stuff up. All right, so I was good to you. I gave you a cosine A is equal to, so we can just type that in. And 7 over 25. Now, I can't put this whole thing into my calculator. Don't put a radical in there because you'll end up with some ridiculously dumb answer. You don't want to do that. But we are going to type everything that's under that radical in. So we'll go over to our calculator and clear out all this. Oops. Escape. Get rid of that. All right, so control division. And then it's 1. Is it minus on top? I always forget. 1 minus parentheses. And then it's control division, and it was 7 over 25, I believe, right? 7 over 25. All over 1 plus parentheses, control division, 7 over 25. And hit enter. I get 9/16. So I come back to my thing. I say, well, okay, this is equal to plus or minus the square root of 9/16, which I don't know why I made this radical so big. Let me kind of make that a little bit smaller. Well, that's equal to plus or minus 3 over 4. Now, I have to decide whether it's plus or minus. Now, hold on a second. If my angle was in the 4th quadrant, angle's here, that means it's between 270 and 360. And I divide those by 2. That means it's between 135 and 180. That puts it into the 2nd quadrant. And what do I know about tangent in the 2nd quadrant? It's negative. So the answer here is negative 3 over 4. Even though my answer sheet says positive 3 over 4, it's absolutely negative 3 over 4. Tricky question. All right. Starting with this, derive this. Well, we've already done it twice, so it shouldn't be difficult. So it said starting with, I forgot what I was doing. So starting with, the reason we put this on here is because it was on a Regents exam a few years ago. So starting with sine squared A plus cosine squared A equals 1. We want to derive this formula right here. Let me get it. So how can I get tangent and how can I get secant? Those are the two things I want to really think about. Well, secant is 1 over cosine, and tangent is sine over cosine. So it seems like it should be obvious to me that if I divide this by cosine squared, theta, and this by cosine squared theta, or in this case a, sorry, then this would give me secant, this would give me tangent, and oh, lo and behold, if I divide this by cosine squared a, that gives me 1. So this is tangent squared a plus 1 equals secant squared a. That's it. Find the exact value of the tangent of 2a. Another one of those formulas I just have not bothered to memorize. Tangent of 2a. Why? Because it's on the formula sheet. Tangent of 2a. 2 tan a over 1 minus tan squared a. So 2 tan a over 1 minus tan squared a. Go back, take a look. Is it right? Did I get it right? Take a second look, take a third look. Don't want to make that mistake. Everywhere I see a tan, I will replace it with parentheses. Squared. That's a squared. So, come up here, grab a little red. Let's see. Oh, I didn't give you tangent of A. I gave you cosine, and I told you it's in the third quadrant. So if I draw a quick little triangle in the third quadrant, A, and it's cosine A, not 8. Cosine is -4 over hypotenuse 5. Well, I think all of you, without any work, know that this is a 3, 4, 5 right triangle. In the second quadrant, oh my goodness, I just realized we're in the third quadrant. Guys, I should not have drawn that triangle there. That would have all but messed me up badly. So, our triangle should have been drawn in the third quadrant with adjacent over hypotenuse. And then once again, let's just real quick recap. That should be a 3. But it's coming down, it's negative. Now, what do I know about tangent in the third quadrant? That's right, it's positive. So, positive 3 over 4 over positive 3 over 4. Now, you don't need to do this in your head. Just come over to the old Taschenrechner. That means calculator. Get rid of all this crap. So I go control division, and then it's 2 parentheses control division. What did we say this was? 4/3 or 3/4? 3/4. 3 over 4 all over 1 minus parentheses control division 3 over 4. Oops, forgot the over. Or I just missed it. 4 squared. Make sure you put all the pieces in. Make sure it looks right. 24 over 7. There's my answer. 24 over 7. Bam. We're almost halfway through. When does cosine equal sine? 45 and 45, 30 and 60, 30 and 60 and 30. Remember, cosine and its cofunction, sine and its cofunction, cosecant and secant, tangent and cotangent, they always equal each other when the angles add up to 90 degrees. So all I got to do is 5a minus 12 plus a equals 90 degrees. And then just solve that. I get 6a equals I even wrote 90 degrees on my I even wrote 90 degrees on my answer key here and just bothered to set them equal to each other. It's so easy just to set things equal to each other and just do it the wrong way, but they add up to 90 degrees. Set them equal to 90 degrees, and I get a equals 15. If you just divide 90 by 6, you get 15. Uh-oh. Tangent. Let's see. When is tangent undefined? Tangent is sine of theta over cosine of theta. And tangent is undefined whenever cosine is equal to 0. Well, cosine is equal to 0 at 90 degrees and 270 degrees. So every time you see one of those, you will have an asymptote, or pi over 2. We've got a big, thicker one. Pi over 2 will have an asymptote here at pi over 2. And at 3 pi over 2. and at negative pi over 2. Every 90 degrees and every 270. If you remember correctly, tangent is undefined at all the odd pi over 2's. Cotangent is odd at all the pi over, or all the pi's, or undefined theirs. In between all those are zeros. Do you remember when we said a few minutes ago, when does tangent equal 0? Tangent equals 0 at 0, pi, and 2 pi, or 0, 180 degrees, and 270 degrees? Yep. And so then we remember that tangent is an increasing function from left to right. So I just draw a tangent. It's this wavy thing. It's waving goodbye. Because if you don't study, I'm going to wave goodbye. Actually, I'm going to wave hello when you come back to my class next year. Work hard, kids. All right. Verify this identity. Oh, crap. So remember, when you're verifying identities or proving these, oh, what's the range and domain? I forgot to do that. So the range is all reals. So negative infinity to positive infinity. The domain is x is in the set of all reals such that x cannot equal plus or minus pi over 2 or plus or minus 3 pi over 2. That's it. All right. Verifying identities. So you only mess with one side, not the other. So we're going to mess with the most complicated side. I don't know. Why don't we just get rid of the parentheses, distribute? So I get secant squared x minus secant x cosine x equals tangent squared x. Remember, you can't mess with that right side, so I'm going to have tangent squared x. Just keep coming along. Don't play around with it. Well, let's figure out what this is. Because this is just secant squared. I might change that. I might not. I don't know. So let's see. So I'll just rewrite secant squared x minus 1 over cosine x times cosine x over 1. Isn't that what that's equal to? Sure. Secant's 1 over cosine, and cosine is just, I can put over 1. Well, these just cancel. So I'm left with secant squared x minus 1 equals tangent squared x. Well, what is secant squared x? Isn't secant squared x really just tan squared x minus 1 or plus 1? Isn't secant squared x tan squared x plus 1? That's one you have to memorize. So I'm replacing that with that. Minus 1 equals tan squared x. Well, what happens to the ones? They cancel, and I end up with tan squared x equals tan squared x. So much fun. Oh, we're almost done. All right. Solve for all values. Okay, it's got to be on there. It's going to be on there, kids. I'm not pulling any punches. It's going to be on there. Let's set this thing equal to 0. So we're going to do 2 secant squared theta plus tangent theta minus 5 equals 0. You can't factor this because this is a secant and this is a tangent, and they can't be factored. So we are going to have to replace secant squared. You can't replace a plain old tangent, but you can replace a squared. And if I remember correctly, I just did it. That's tangent squared theta. Oh, pen's starting to act up. See, I told you I was jinxing myself. Plus 1. And I'll just copy everything else down. Tangent theta minus 5 equals 0. All right, we're getting close to the end. Distribute. I get 2 tangent squared theta plus 2 plus tangent theta minus 5. That's close to my head, so I got to clean it all up. So this is 2 tangent squared theta plus tangent theta minus 3 equals 0. I feel like I've done this one before. I've done so many problems before, I don't even remember which ones I've done and which ones I've not done. So tangent theta, I'm gonna work backwards. I'm gonna cheat. Tangent theta. Nah, you guys can cheat. I'm gonna do it. I know this is 2 tan theta, and this is tan theta. I could use menu 331, but I'm not going to. They got to add up to +1, so this is +3, and this is -1. So this gives me tan theta equals 1/2, which I have no idea when that equals, and tan theta equals -3. I also have no idea when that's equal to. What do you think? Should we check our answers? Because, you know, I think I'm right. I'm in pretty good shape. I think I'm right. Let's check. I don't know. Let's check. Let's just see. So we'll go menu 3, 3, 1. Yeah, it's a second degree polynomial. What do we got? 2, 1, and -3. So 2, 1, and -3. And we'll just click OK. Yeah, I think that's my quadratic. X squared plus x minus 3. Yeah, no problem. I got it. I'm good. And I get -3/2 and 1, just like, wait. What? I don't think I got that. I got 1/2 and -3. -3/2 and 1. Did I mess my factoring up? Oh no. Can't believe I did that. That's why, guys, it's nice to be able to factor, and I love and I want you guys to be able to factor. But why not use the tools you have to check your answers? The +3 goes here, and the -1 goes here, because they have to add up to +1. Mine other ones added up to like something ridiculous, like 5 or something stupid. All right, so let's get that done right. This is going to be -3/2 and 1. Let's make sure. Is that what I got? -3/2 and 1. Ah, that makes more sense. Okay, let's get this away from my head. So theta equals, and I know this one's theta equals 45 degrees. I am going to include that one. That will be one of my answers, maybe. But I have no idea about 3/2, so let's go inverse tan. Inverse tan, oops, crap. Oh, that's still up there. So, trig, inverse tan, was it 3/2? I can't remember. Yeah, 3/2. 3 divided by 2, I get 56.3099. 56.3099. Directions said rounded to the nearest minute. Oh my gosh, you gotta be kidding me. Gotta DMS this thing? Book. DMS it. Let's see. 56 degrees, 18 minutes. So let's go over there. 56 degrees, 18 minutes, 35 point something seconds. Well, if I want to round this to the nearest minute, that's 56 degrees, 19 minutes. Because remember, it's 35 seconds is over a minute. So I'm not going to actually keep this angle because it's negative. I need the ones in the third and fourth quadrants. That is one amazing drawing. That kind of looks like the Hawks drawing right there. Not going to lie. Hawk, that was one of your drawings, kid. All right, so let's get this. Let's see what we got here. First of all, I want to see, does it restrict where I got? Okay, I'm going from 0 to 360. So I'm going to use them all. And so let's see. Let's do these. These are easy. 45 degrees, we're going to keep it. Where else is tangent positive? Third quadrant. 180 plus 45 is 225. All right, so I got the two easy ones. Now I need to get this in the second and fourth quadrant, because that's where tangent is negative. So I'm going to come back to my calculator. I'm going to do 180 minus this. It's not going to give it to me as in DMS, so I'm still going to have to DMS it. DMS. 123.41. 123 degrees, 41 minutes. Now I have to do 360 minus that. Now I'm going to go back to my calculator. I'm going to do 360 minus, and then I go back up to that thing I want to subtract, which is this 56 up here. Hit enter. And right now I'm also going to DMS it. I'm going to do it all at one time. So I'm going to do 360 minus this, and whatever answer I get, I'm going to immediately DMS it. 303.41. 303.41 minutes. All right. Now, all we have to do is match some functions. So what we're going to do, kids, is we're going to find all the easy ones. I'm going to go find sine first, because that's the easiest one. See, those aren't sine. Well, those look like terrible. Hope that comes out better looking for you guys. Oh, I think I found sine. Oh, crap. That looks like sine to me. Wait, look at the directions. Directions said, oh, I have to write the exact function for sine and cosine. Oh, crap. All right, so I've got my midline. My midline looks like it might be at -2. So at the end of this thing, I'm going to have a -2. And let me erase all my mess that I have there now, because I got a mess. So my midline's at -2. My amplitude goes up 2 and down 2. And since it starts here and goes up first, I know it's +2 sine. And then it finishes one full curve, and that's 2 pi. So that means it's just x. So 2 sine x -2. All right, let's go find cosine. Ah, I believe this is cosine. Now let's see. The top here is at 4, and the bottom here is at -2. That's a distance of 6. So my midline's got to be right here in the middle. It goes up 3 and down 3. Notice we're starting at a minimum and finishing at minimums. Notice this is also 2 pi here. So my f of x here will be -3 cosine. I'm going to finish 2 full cosine curves in 2 pi. So that's 2x. And my midline is up 1. So +1. There it is. All right. Next thing I'm going to find is tangent, because that's pretty easy. Tangents are these wiggly ones. Oh, look, they're right here. So the wiggly ones, and if you remember, tangent goes up. So this is y equals tangent of x. Well, cotangent comes down, so this must be y equals cotangent of x. Got those done. The next ones I'm going to find, I think, are my cosecant and secant. So that looks like these little U-shaped things, right? So let me go through and put points on all these things. And let me connect them. What function does this red thing look like? Doesn't that look like sine? And then what rides on sine but cosecant x. If I come down here and I put dots on all these and I draw this in, isn't this the cosine curve? Starts at a max, ends at a max. And what rides on the cosine curve but secant x? This here looks like the tangent curve kind of got reflected over this line y equals x, which is what an inverse is. So this must be y equals tan inverse of x. And these are my other two options. One of these is sine inverse and one of these is cosine inverse. Since sine goes through the origin, and if I reflect over the line y equals x, that point doesn't change, this one has to be the y equals sine inverse of x. And that makes this one y equals cosine inverse of x. That's it, kids. How'd you do? I hope you did well. I really did. I hope you did well. Hey, if you need help, come see me. Rewind this, check these videos out. All the videos from all the lessons we've done this year are on there. So if you know you're particularly weak at one thing, Go download that video. Go watch that video. Go download the notes, print them, and practice some problems again. Kick butt on this test. Work hard. I know you guys can do it. All right? It's been fun working with you, even though it's early in the morning and I don't have a cup of coffee. But have a good day, kids. Good luck on the test.